Okay, guys, so looks like there was some problem with today's recording. So I'm just creating a summary of what I covered today. If anyone needs help with that, you can go through this video, okay? So this is the second class for the chapter 1, which is real numbers. So what we had discussed in the previous class, that was just an introduction, and we understood what is Euclid's division lemma. Okay, Euclid's division lemma. It's very similar idea which you already know as division algorithm. You know that dividend is equal to divisor into quotient plus remainder. I think everybody knows this. We have been doing this for years. I think dividend is equal to divisor into quotient plus remainder. So this Euclid's division lemma just takes the same idea, and how it defines is, if you have two numbers, let's say two positive integers a and b, in such a way that a is greater than b. So for example, I can take a is equal to 3526 and b will have to be smaller than a. So any number smaller than a we can take. So let's take 255 for that example, for that matter. Okay. So a and b are two positive integers. If you have something like that, then the number a can always be written as b times of some number q plus r. Now look at this and look at the division algorithm. Don't they look very similar? So basically what are they doing is they're taking the number a and dividing it with b. So you take your a, divide with b. What do you get? You get the quotient as q, and somewhere down you will get the remainder r. Now everybody knows that the number a, which is the dividend, will become equal to b times of q plus r. This is what your Euclid's division lemma tells you. Okay, and then it also just adds this information that the remainder r, which you already knew that remainder will always be less than the divisor. No? So that is what they have written mathematically. So you should write that remainder is always less than the divisor b. And you also know that when you do some division, remainder will be either 0 or greater than 0, right? Either 0 or some number greater than 0. So that is what you can write it as. Remainder is either 0 or greater than 0, but it has to be less than the divisor b. Okay. So you can go through yesterday's video, even though the audio was not very clear in the yesterday's class. So, but still you should be able to understand it. So that was a Euclid's division lemma. Okay. And then yesterday's class we had also seen just the introduction of Euclid's division algorithm. Euclid's division algorithm. Now, what is that? What is Euclid's division lemma? And then we are doing the algorithm. So this Euclid's division algorithm basically uses the same idea which we just talked about, Euclid's division lemma. That is, a is equal to bq plus r. But you have to do it again and again repeatedly until the remainder becomes 0. Okay, and in the step when it becomes 0, the divisor at that step, that becomes the HCF. So what is this Euclid's division algorithm used for? It is used for finding the HCF of two numbers a and b. So if I have two numbers a and b, again same manner, a will be greater than b and a, b are two positive integers. In that case, I can find the HCF of these two numbers. Okay. So anyway, we had a question in today's class which we discussed related to this. So we'll take up the same question for Euclid's division algorithm. Let's see how we find the HCF of two numbers using Euclid's division algorithm. So as you can see, this was the first question which we discussed today. Okay, so what does the question say then? Find the HCF of these two numbers using Euclid's division algorithm. I think it should be straightforward. You have to understand there are two numbers, A and B. Which one should I call it as A? Of course, the one which is the bigger one. The bigger one number we will call it as A, and the smaller number we will call it as B. Okay. And then let's write the Euclid's division lemma form. So the bigger number 867, I have started from here. This can be written, do the division first, okay? Divide 867 by 255 by the number B. And once you do the division, what is the quotient here? I got a quotient of 3 and a remainder of 102. So write it in the division algorithm form or Euclid's division lemma form for that matter from now on, okay? So 867 can be written as 255 into 3 plus the remainder 102. And whatever is, since in this step, as we can see, the remainder is not 0 yet, right? Remainder is 102. So we will have to apply the same logic one more time, but this time, this divisor will become the new dividend. We have to divide 255 now, but with what? With the remainder of the previous step. So whatever is the remainder, as you can see in the division, remainder becomes the divisor and the previous divisor becomes the new dividend. Okay, previous divisor becomes the new dividend and the previous remainder becomes the new divisor. All right. So 255 and 102, do the division again, like here I have done. So once you do this division, I get a quotient of 2 and remainder 51. So as you can see, the remainder is still not 51. So we'll have to continue doing this one more time at least. So, but first of all, let's write this down in the form of Euclid's division lemma. That is 255 can be written as 102 into the quotient 2 plus the remainder 51. Okay. And like I said, take the previous divisor as the dividend and the previous remainder as the divisor. So this time we have to divide 102 by 51. And lucky for us, 102 will get divided by 2 and there will be no remainder. So remainder becomes 0. So 102 will be equal to 51 times 2 plus 0. Now, what did I say? If the remainder becomes 0, in this step, whatever is the divisor, that is 51, that is what becomes the HCF of the two numbers. So the divisor of the step where the remainder became 0 becomes the HCF. Okay. So this is your Euclid's division algorithm to find the HCF. And notice one more thing, that some people might want to write this division. I have done it in 3 steps, but you might also want to write it like this. You see 867 you are doing, you started the division with 255, right? What you do is you write it 3 times. It will be 765. You get 102. So now this remainder becomes the divisor. So write it here itself and bring your 255 as a dividend. 255 here. Now 102 will go 2 times. You will get 204. And 51 is remaining. So this is the remainder of this part of division. Now again, this will become the divisor. And what will be my dividend? It will be the divisor of the previous step. That is 102. And it will go 2 times. It will become 102. And the remainder will become 0. So you might want to write like this also if you like. Okay. It will help you understand that the remainder of the previous step becomes the divisor now, and the previous divisor becomes the new dividend. Okay. So write it whichever way you feel more comfortable. So that is the Euclid's division algorithm for you. And then we discussed one more question today, which was a little bit of application of Euclid's division algorithm, where using the Euclid's, like the question says, find the HCF of the two numbers. And once you're done with the HCF, once you have found the HCF, like you see, we applied the Euclid's division algorithm and found the HCF to be 127. Okay. we followed the same steps like the previous one, and we found the HCF to be 127. And once you have found the HCF, what are they saying? Express this HCF which you found in the form of this thing, in this form. Now, what is this form? 1651 should be multiplied to some integer m, okay, plus 2032 should be multiplied to some integer n. When you solve this, of course, it should be equal to the HCF, that is 127. But that 127, you have to represent it in this form. And the way to do this is very simple. You just have to take up the few steps, whatever you had done in the Euclid's division algorithm before here itself, okay? So as you can see, the first step, the two numbers were 2032 and 1651. And notice that these are the numbers which is they're asking you to write that 127 in this form, okay? 1651 is here, 2032 is here, okay? So these numbers are not coming from magically somewhere else. They are from the two numbers which is given to you, okay? So you have to represent 127 in the form of these numbers multiplied to some other number m and n. Yeah, so what I was saying is, in the Euclid's division algorithm, we had taken up these steps, right? So I'm calling this step as the first equation and this one as the second equation. You would never need this last one because the remainder has become 0 over here. So you don't need this one. So as you can see, 127 was our answer, the HCF. So I am taking this second equation to write 127 is equal to what? This is just an equation, right? So I can transpose this part to the left-hand side. And what will this 127 equal to? It will be 1651 and the minus of this whole thing when it goes to the left-hand side. So see that from here, this is what I have taken. From second equation, I have written 127 is equal to 1651 minus of 381 times of 4. So this thing has come from the second equation. Okay. See, so in this equation, in the first step itself, I have got 127 in the form of some number 1651, but still my 2032 is missing. So how do I get that? So there is this 381 from the first equation. Look at the first equation. There was a 381 here. This 381, can I exchange? I can put the value of 381 . Oh, okay. So I think I put a minus over here. So this is not a minus. I think I was trying to explain that when you transpose it to this side, it will become minus. So that's when I would have written this minus and I forgot to remove it. So this is not negative, okay? It's, remember, it's a positive number. So is there a way I can erase it? Let me see. Yes, I can. Good. So yeah, what was I saying? I had already taken what value of 127 from the second equation, 1651 minus 381 times 4. And then you do one more replacement. You replace the value of 381 from the first equation. Now what is this 381 equal to? Transpose it to the left hand side and 2032 minus 1651 times of 1. This is what I have written. 381 is equal to 2032 minus 1651 times of 1 coming from the first equation. And then there is a into 4. 381 into 4 was there already. No? So that into 4 you will have to do again. So don't forget that. Into 4. So this whole thing is 381 and then you multiply 4 to that. Okay. After this, it's just simple calculation. Move around the way, numbers here and there to arrange it into the form which they asked you to write it. Okay. They asked us to write in the form of 1651 times m, 2032 times n. So let's rearrange the numbers. What can I do? This is distributive property. Multiply 4 to the first one also and then to the second one. So once you multiply here, what do you get? 2032 times 4. And then this whole thing times 4. So since there is a number 1 here, so 4 ones are 4, that's what only one thing will be remaining. And 1651 here. Remember, don't multiply these things. We don't want to change this thing. We don't want to multiply and get a big number like 4064 over here or whatever. Whatever you get after multiplying this. I want to keep this value 2032, 1651, 1651. I want to keep all those things there in the equation because I want to write 127 in the form of these numbers, not as a value. Because when you simplify this whole thing, actually it will become 127 only. So we are not, that's why we are not doing any simplification here. So again, this 1651 and 1651, these are the two terms which are like terms. I can bring them together, 1651 and 1651 times 4. And I think I had explained this in the class today enough number of times. So hopefully you understand. I'm taking 1651 common. And from the first one, there's only 1 remaining. And from the second one, there is 4 remaining. So this becomes 1 plus 4. Okay. When you take 1651 common from these two, it becomes 1 plus 4 in the bracket. And this part I have written as it is. Okay, no, there is small change. There's this minus, I made it into a plus. Why did I do that? Because look at the question. In the question, they want a plus 2032 times some number. So even though I got a minus over there, I changed it to a plus. And then this minus, I have to transfer somewhere. I just transferred it to 4 and it became minus 4 over here. This also I had explained in the class. When you have two numbers like 5 into 2 like this, you can always write it as 5 into minus 2. You can transfer this minus sign to the other integer. Okay. Multiplication is commutative. So minus is basically minus 1. You can multiply to 2 over here. Okay. So now it starts looking like what we want. So 1651 times 4 plus 1, 5, and 2032 times some other integer minus 4. Okay. So this is what I have written, 1651 times 5 and 2032 times minus 4. This is what they wanted. 127 to be written in the form of 1651 multiplied by some number and 2032 multiplied by some other number. So this will become our M, this will become our N. Right, so hopefully you should understand this type of question where you have to represent the HCF in the form of some number like this, okay? So I'll give you more questions to practice tomorrow and it will become more clear after that, okay? So that's it for today's class. See you guys tomorrow.